to talk about some ways of displaying frequency, but to do that, let me set up a problem we're going to use for that. So some background, I recently ordered 200 half-dollar coins. I ordered them from my bank, so that's $100 worth of 50-cent pieces. I opened them up and sorted them by year, and then I grouped them by decades. And looked at each of the stacks of coins. So this picture right here is the picture of the coins from the 70s. So notice that I have them stacked with the 1971s, the 1972s, 1973s, 1974s. There's a space here for 1975. I'll explain that in a moment. 1976, 1977. There's a space for 1978 and 1979. Okay. So you can very quickly see that the 1976 was the most common type, with 1972 the next most common, and 1971 the next most common. Okay, so first of all, this little asterisk here, that's to denote the fact that even though they're labeled as 1976, and that's the year theoretically that they were minted, they're actually bicentennial coins. So those were marked with 1776 to 1976. And they actually started to be printed, or I should say minted, I guess, in 1975. So there are no 1975s, not because I didn't get any, but because there are none. So anybody who was to do this same experiment should get a gap at 1975. Now, this gap in 1978, that is just because I didn't get any. It's a reasonable thing because that was the year with the lowest number of coins minted from 1970s, but they do exist. Okay, so let's move on. I also did not get all of them in the 70s. Some of them were from the 80s, so here's my group from the 80s. Some of them were from the 90s. Here are those from the 90s. I also got some from 2000, 2001, and 2018. I didn't take pictures of those here because they're only 3 years spread out over a total of 19 years, so it would be pretty sparse looking. Okay, and all of this in here, if you want to pause and read what it is written, you can, but it's just explaining the things I have verbally said. I should say orally said. Anyway, moving on. So, what I've done is I've recorded each of the years that that showed up in the 200 coins that I had, and recorded the frequency of the number of coins for that year. Okay, so frequency is just a count of how many occurrences there were. So there were 24 coins minted in 1971. There were 25 coins that were minted in 1972, and so on. So you can see I recorded everything from 71 to 2018. I didn't want to have a whole bunch of 0 rows here, so I just said from 2002 to 2017 overall, there were 0 coins. Okay, now the first thing I'm going to do before I continue and talk about the frequency distribution itself, I want to talk about how I can look for errors. So, of course, I could just go through and check these individually, but that takes a while. And one way I can do a quick check is to make sure that since I know I had 200 coins, that's how many I got from the bank, and I confirmed it while I was opening up the rolls. None of the rolls were missing coins or anything. There should be a total of 200 of these frequencies. So if I take the frequencies, 24, 25, and so on, I should get 200. And this takes a little bit of time, but not nearly as much time as it would take to check each number for the frequencies individually. Of course, I'm skipping over the zeros. I'm not writing +0 every time I see a +0. And then here I have a 4, 4, 7. Getting near the end. And then I have a 3, a 5, and a 14. Okay, so what I'm going to do here is I'm going to be a little smart about this. I'm going to group them together. So I'm going to group this one with this 24, and that gives me 25. Okay, let's see, I'll take this 6 and this 4 and this 5 and this 5, and I get 20. Okay, I'll take those and get 10, and so on. Let's see, 7 and 2 and 1, that's a 10. Of course, I could bust out a calculator, and if we were to be doing this a lot, we would definitely be using something like Excel in order to keep track of all these, in which case we just use a sum function. Okay, this is looking pretty good. So let's see, I have 25. Let's do this 8, 13 together. That's 21, and 21 and 29 give us 50. Cool. Okay, so we have 25 and 50 is 75. 75 and 25 is 100. 120, 110. Oh, sorry, 120, 130, 140. Let's see, 160. 162. 166. And that gives me then 170. Let's do this one and this one to give us 10. So then that's 180, 181, 186, plus 14 is 200. Yay! Okay. So obviously this is very messy, and if I were to write this out as an official argument, I would not write it this messy. But again, if I were to be officially doing any of this, it would be in Excel. This is just for a quick demonstration. Okay, so moving on. Notice that if I wanted to make this chart, this distribution into a chart, I can make a frequency distribution table, chart, that mimics the stacks of coins that I have, because these stacks of coins give us a lot of information. Like I already said, we have this one had the max number, okay, and we can see that over here. That was 29. That's the max number from the 70s. It's actually the max number for all of them, okay. So that that picture is really valuable, but I don't normally have a camera around when I'm dealing with data, and even if I do, data is often not something I can stack like coins, right? If I'm counting how many people voted in an election or something, those aren't coins I can stack on top of each other. So I want a visual representation of data that mimics these stacks of coins. This is essentially going to be what's called a histogram. Technically, for histograms, you need slightly different situation where you have quantitative data where you've separated it into ranges, classes, I should say, and go from there. So this, for a lot of people, this doesn't really fit the criteria of being a histogram, but it essentially is. Okay, so what I'm going to do is I've already labeled my axes here. I've made my vertical axis go up to 29 because that was my maximum number here. On my horizontal axis, I have each of these line segments here is labeled from 71 up to 2001. And then I skipped over all those ones here that were 0, okay? And then have one here for 2018, okay? So what I'm going to do is I'm going to make bars. This is a type of bar chart where the height of the bar will correspond to the frequency. So for 1971, I want the height to be at 24. And essentially that's coming from the fact that I am thinking of each piece of this bar. So there's a piece, and so on. If we were to keep stacking them up, these are essentially corresponding to coins. And so in the end, we would end up with a stack of 24 coins, so our bar should reach this height. Now I want it to look a little bit nicer than that. So what I'm going to do is I'm going to use some lines here to make this easier. So I'm going to take this line here, and then I'm going to do the same thing here. Oops, I gotta tell it I want to do another one. Okay. And then finally, one more. I'll just move it down. Okay. Not perfect, right? I'm going to clean this up a little bit off camera, but that's going to be approximately my bar. Okay. So what I'm going to do is off camera, I'm going to draw a bunch more of these so we can then compare it to the pictures we already have. So I'll be back. I'm back, and I have drawn the rest of my chart. So we have, again, just reminding you that frequency is over here. That's the vertical axis unit, and year is down here. And so we see that we have all these various heights starting at 24, going up to 25, going down to 8, and so on as we move across here, and those correspond to our frequencies in our frequency chart. Okay, so especially this part here between 71 and 79, compare that to our picture up here, and we see that it's essentially the same thing, just squished, right? This is more wide and short. This is more tall, right, and narrow. But we can see it's the same idea. We have it goes up and then down, and then up, and then a 0, and then back up to the top, and then down. Okay, going back up here, same idea. We start up here, go up a little bit, down, up again to 0, back up to our maximum, and then down. Okay, and then of course I didn't do this last part on the other one, but anyway, the point is we have that they mimic each other, and that's precisely what I wanted, right? I wanted a chart that that mimicked the stacks of coins, and the point is we can make this type of chart with lots of other types of data, not just things we can physically stack. So just to make sure that we're getting things, let's do another much simpler one. Also, it's a chance to talk about a similar but not quite the same chart. Okay. Here, this is just describing some of the things we've already talked about. The fact that in such a chart, we can easily see where the peaks are, how spread out the data is, that type thing. Okay, so for all of these 200 half dollars, I also kept track of the mint marks. Okay, there were 53 of the half dollars that had P mint marks, which means it was minted in Philadelphia. There were 147 of them that had D mint marks, which means they were minted in Denver. And so we're going to make a chart with this. Now, P and D, that is qualitative data. It's not quantitative data. So the chart we get is definitely not a histogram. Histograms are when you chart quantitative data, and the y-axis is frequency, and then there's a few other requirements. So in this case, we definitely don't have a histogram, but we can still make something similar. It's still a bar chart, and because it's qualitative data, I can actually make it into what's called a Pareto chart, which means you start with the highest frequency and work your way down. Now, in our case, there's only 2 sets that we're dealing with, so working your way down isn't that interesting. But if you had more than that, then you can imagine you'd start with the highest and then go down from there. Okay, it can only be done with qualitative data, because if you were to use it with quantitative data, then you'd be messing up the order of the x-axis, or I should say just horizontal axis, and that would be confusing. In fact, there was a bit of a scandal recently with COVID data where one state was reporting their data where they purposely put the highest numbers first and then worked downward, so it looked like they were getting fewer and fewer cases over time, whereas really they just mixed up the years and made it into a Pareto chart. Okay, so let's do this. So since there were more D's than P's, I have put D first on my horizontal axis, and then P. Okay, So to make this one look a little bit nicer, I'm going to do the same thing I did for the previous one off camera. I'm going to use the rectangle tool to make my bars. Of course, usually if you're going to make a lot of these charts, you're going to use technology to do it. And by technology, I don't mean drawing pictures in Notepad or in this case, OneNote. I mean actually using something like Excel or some software dedicated to making charts. But again, this is just a demonstration for what you would maybe be doing by hand on pencil and paper, in which case you would be using rulers. Anyway, moving on. So we want 147. In order to make this reasonable in terms of the amount of time it takes, I made my scale so that each mark here corresponds to 10 coins. So 147 would go up to almost 150, but not quite. Okay. So about right there. And then 53, we would go a little bit above the 50. Not too much. Basically the same amount above 50 that we did for the other one. So that one actually was a little bit low. Let's fix that. Let's go a little bit higher. There we go. Okay. And there's my chart. So in this case, since there were only two values I needed to chart, this went very quickly, but you get the idea. Even if there were, say, some minted in San Francisco, that's where another mint is, and so there were some S's, then I would then just continue to the right. I would make another mark here for S, and then I'd make a bar corresponding to the number of coins with that mint mark, and so on. Okay? So that is it. Thank you very much for watching.